This example shows how to use the Serial Wombat pins as digital outputs through Arduino. In order to do this, download the Serial Wombat library. Another video is available on how to do this. See links in the description below. Add the include serialwombat.h. That allows you to access the library. Declare a serial wombat. This is outside of your functions as a global definition. Determine a pin that you want to use. The Serial Wombat 4A, which is serially controlled, has 4 output pins. The Serial Wombat 4B, which is I2C controlled, has 3 outputs on pins 1, 2, and 3. In this case, we'll be using pin number 2, but you could use 1 or 3 instead for I2C, or 0, 1, 2, or 3 for the serial version, the UART version. Initialize your communications. In this case, we're using I2C, so we'll do wire begin, and then we'll say Serial Wombat begin, handing it wire, and telling it the I2C address of the Serial Wombat that we're using. In this case, ours is configured to 6C, so that's the address we're using. Use the Serial Wombat pin mode to set the pin as an output. This format matches the digital pin I/O that's used by other Arduino pins. In our loop, we will alternately set the pin high and set the pin low, with a delay of 1,000 milliseconds in between. We can see in the video that our LED is going on and off as we turn pin 2 high and low. Shown here is our circuit configuration. The Arduino is receiving power and data from the PC. It's running our sketch inside the microcontroller. The Arduino is providing 5 volts and ground to the breadboard. Our Serial Wombat 4B is configured here. Note that you should have a 100 nanofarad or a 0.1 microfarad ceramic capacitor attaching the VDD and VSS pins to ensure proper operation of the Serial Wombat. There are 2 pull-up resistors. In this case, I'm using 5.1K. Values can vary. 5.1 works good for me. You can choose values according to your needs. The SDA and SCL pins are attached to the I2C pins from the Arduino Uno. We have a resistor attaching pin 2 to our LED, and our LED is connected to ground. The Serial Wombat open source project was created by Broadwell Consulting Inc. Broadwell Consulting Inc. provides help developing medical devices with a focus on developing embedded firmware, which is compliant with IEC 62304, ISO 14971, and ISO 13485, as well as remediation assistance for products already in production. For more information, contact John at Broadwell Consulting. Support requests for Serial Wombat should be sent to help@serialwombat.com and will be answered on an as-available basis. Also, feel free to leave your question in the comments below. Questions sent to John at Broadwell Consulting about the Serial Wombat will not be returned.